So now I'm going to give an overview of the code. First, I'll start with the broker, since this was modified to implement load balancing. I decided to have the broker group split up by topic, so there are 3 topics per group. I added a group quorum parameter, which basically tells the group size for each broker group. I have the default set to 4, but it's taken as a parameter, so that can change. So then in broker middleware, so I define the group 1 topics here, group 2 topics, group 3 topics. And I have the if the broker group path for each broker group. If it doesn't exist yet, then I have broker create a node for that group path. And then I set watches to see if the each broker group has reached its quorum. And assuming for each group the quorum has not been reached, then I have that broker create a node for itself under that parent node for that group path. And here I have it waiting for each of the quorums to be reached. Then here I have watch mechanisms for each of the quorums. So quorum for the group for the first group of topics, second group of topics, and the third group of topics. And then here in the subscriber, then it checks if the dissemination strategy is broker, and then it checks for changes for the leaders for each of the 3 broker groups. Now for the broker, I also changed the way that it registers itself. Now, given that each broker is assigned to a broker group that only uses a subset of the topics, then now I have it register similar to how the subscriber registers, where it actually has a topic list. And here the topic list are the topics for its particular broker group. And in the discovery application here, then I have it check to see which, assuming it's a broker, it checks to see which topic list it has to determine whether it's going to be registered as a broker group 1, group 2, or group 3 leaders. And then also for the lookup, then I do it similar to how the lookup is done for the subscribers, where it only looks up publishers that publish the topics for its particular topic group. Actually, I'll go to the broker middleware just to show this as well. It supplies the topic list for this broker to look up only publishers for that particular topic. All right, so now I'm also going to go over how ownership strength was implemented. And the way I have the ownership strength such that the value for ownership strength is assigned essentially on a first come, first served basis. So early publishers that register earlier will have lower ownership strength values and therefore have priority for ownership strength. And that's assigned different ownership strength depending on which topic it's disseminating. And if we go to the publisher middleware, so in the place where I have it register itself in the Zookeeper tree, then for each topic, then I have it create a node for itself on an ownership strength tree. And so this starts with an ownership strength path. Then it has a child node for the topic. And under this one, there are two branches. One holds the current value of ownership strength, which monotonically increases so that each time a new publisher registers for this topic, then that publisher takes the current value of the current value node and sets it to ownership strength equal to that value, and then the value of the current for the current value path increments by one, so that the next publisher that tries to register itself for the topic will then get that current value. And then for the subscriber, this gets the part in the code. Okay, so when the subscriber handles topic data, so it receives data for a multi-part bytes array, where the first part is the topic in bytes, and the second is the actual topic data. So I have it get the topic by converting the bytes form of the topic to a string. And then on receipt, I have it check to find the publisher with the highest ownership strength for that topic. And so first, what it does for this find ownership strength method is for each of the children publishers for this topic, it gets a history quality of service. And it makes sure first that history quality of service matches, because if the publisher has too low a quality of service for history, it can't be considered to receive to disseminate information to that subscriber. So I check to see if history quality of service matches, and then I see if it has an ownership strength where the value is less than one that's already been seen. If it does, then it sets the publisher highest ownership strength to that particular publisher, and I return it. And what I essentially do is it has the publisher with it uses a filter to filter only on the publisher with the highest ownership strength. So it checks to see if the topic message ID is equal to that publisher. If it is, the subscriber takes that data. If not, it rejects it. Right, and then the final piece of the puzzle is history quality of service. I use a simplifying assumption here where for the history quality of service parameter passed to a publisher, every topic will have that history quality of service assigned to it. And I do a similar thing for the subscriber, where it will take a single history quality of service parameter. The publisher stores its history quality of service parameter in a history quality of service tree in the Znode hierarchy. And the subscriber will, on its side, in its find ownership strength or we'll rather find the publisher with the highest ownership strength method. It will check the history quality of service first to make sure it matches its own history quality of service. Otherwise, it will not connect to that particular publisher. All right, and then for the last thing that I wrote, then just for ease of access for using Zookeeper, then for nodes that are not ephemeral nodes, then it will keep the data for those nodes even after all of the Python scripts have closed out. So I created a script, Zookeeper cleanup, which cleans up all of the nodes after the program is run. So that way, the next time we try to run a setup, then it will have a clean Zookeeper tree to work with, and that just makes it that there's no lingering data from other runs of this. All right, so that concludes the walkthrough of the code.